Very good morning, my dear fourth semester mechanical and automobile students. Today I will solve two problems. One problem from minor energy loss and another problem is the Venturimeter. First one is find the loss of head when a pipe of diameter 200 mm is suddenly enlarged to a diameter of 400 mm. The rate of flow of water through the pipe is 250 liters per second. First of all, data given D1. This is the D1 diameter of smaller pipe is equal to 200 mm is equal to 200 divided by 1000 is equal to 0.2 meter, because 1 meter is equal to 1000 mm. Then A1 pi by 4 D1 square is equal to pi by 4 into 0.2 square is equal to 0.0314 meter square. Then D2, this is the D2 diameter of larger pipe is equal to 400 mm is equal to 400 divided by 1000 is equal to 0.4 meter. Then area A2 is equal to pi by 4 D2 square is equal to pi by 4 into 0.4 square is equal to 0.1257 meter square. Then data given Q, discharge through the pipe is equal to 250 liters per second is equal to 250 divided by 1000 is equal to 0.25 meter cube per second, because 1 liter is equal to 1000 centimeter cube or 1 by 1000 meter cube. Again, we know that Q, rate of discharge, is equal to A1 V1 is equal to A2 V2. Therefore, V1 is equal to Q by A1 is equal to 0.25, that is Q is equal to 0.25 and area 0.0314 is equal to 7.96 meter per second. Then V2 is equal to Q by A2 is equal to 0.25 divided by 0.1257 is equal to 1.99 meters per second. Then loss of head due to sudden enlargement is given by HE is equal to V1 minus V2 square by 2G. This is the formula for head loss due to sudden enlargement. Putting all the values, we have V1 is equal to 7.96 minus V2 is equal to 1.99 square divided by 2 into 9.81 is equal to HE is equal to 5.97 square divided by 2 into 9.81 is equal to 1.816 meter per of water. This is the required answer. This problem from the discharge through Venturimeter. Question is, an oil of specific gravity 0.8 is flowing through a Venturimeter having inlet diameter 20 cm and a throat diameter 10 cm. The oil mercury differential manometer shows a reading of 25 cm. Calculate the discharge of oil through the horizontal Venturimeter. Take CD is equal to 0.98. First of all, data given. Specific gravity of oil S0 is equal to 0.8. Specific gravity of mercury SH is equal to 13.6. X is equal to reading of differential manometer is equal to 25 cm. Then H, difference of pressure head is equal to X within bracket SH by S0 minus 1. After putting the values, we have H is equal to 25 within bracket 13.6 divided by 0.8 minus 1 centimeter of oil is equal to 25 into 17 minus 1 is equal to 25 into 16, 400 centimeter of oil. Then D1 is equal to diameter at inlet 20 centimeter. Then A1 is equal to pi by 4 D1 square is equal to pi by 4 into 20 square is equal to 314.16 centimeter square. Then D2 is equal to diameter at throat is equal to 10 centimeter. Then A2 is equal to pi by 4 D2 square is equal to pi by 4 into 10 square is equal to 78.57 centimeter square. And CD, coefficient of discharge, is equal to 0.98. You know that the discharge Q through Venturimeter is given by formula Q actual is equal to CD into A1 A2 divided by A1 square minus A2 square root over into 2GH root over. Then after putting all the values, we have CD is equal to 0.98 into A1 314.16 into and A2 is equal to 78.57 divided by 314 minus 60.16 square minus 78.57 square into 2GH 2 into 981 into 400 root over. Here we take G is equal to 981 because it is in CGA system. In MK system, G is equal to 9.81. But for CGA system, it is 981. Then 0.98 into 314.16 into 78.57 divided by square of 314.16 98696.50 minus square of 78.57 6173.24 into 885 into 88. Then 0.98 into 24683.55 because 314.16 into 78.57 is equal to 24,683.55 into 88.588 divided by 92523.26 root over is equal to 21429 into 33 divided by root over 92523.26 is equal to 304.17 is equal to 70451.81 centimeter cube per second, or Q actual is equal to 70,451.81 divided by 1000 is equal to 70.45 liters per second, because you know that 1 liter is equal to 1000 centimeter cube, or 1 liter is equal to 1 by 1000 meter cube. Therefore, 70,451.81 divided by 1000 is equal to 70.45 liters per second. This is the required answer. Now, I will discuss what is Orifice coefficient and derive the relationship between them. Generally, there are three important Orifice coefficient. One is the coefficient of contraction, that is the ratio of the area of the jet at vena contracta to the area of the orifice is known as coefficient of contraction. It is denoted by Cc is equal to Ac by A. Then coefficient of velocity, the ratio of actual velocity v of the jet at vena contracta to the theoretical velocity of the jet. Then Cv is equal to V by Vth or V by 2gh root over. Then coefficient of discharge, the ratio of actual discharge Q through an orifice to the theoretical discharge is known as coefficient of discharge. Then it is denoted by Cd is equal to Q by Q theoretical. Then relationship between the orifice coefficient. We know that Cd is equal to Q actual by Q theoretical. But Q is equal to AV. Therefore, Cd is equal to actual area into actual velocity divided by theoretical area into theoretical velocity is equal to actual area by theoretical area into actual velocity by theoretical velocity. Therefore, Cd is equal to Cc into Cv. This is the most important for exam. Then, now derive continuity equation. It is also one important question for semester examination. The continuity equation is actually mathematical statement of the principle of conservation of mass. This principle states that mass can neither be created nor destroyed. On the basis of this principle, the continuity equation is derived. Let us consider two cross section of a pipe. This is the one of the cross section 1 and it is also another cross section 2-2. Here A1 cross sectional area of the pipe at section 1 this is A1. V1 velocity of fluid at section 1 rho 1 is equal to density of fluid at section 1. A2 V2 rho 2 are the corresponding values at section 2-2. Then total quantity of fluid passing through section 1-1 is equal to rho 1 A1 V1. Total quantity of fluid passing through section 2-2 is equal to rho 2 A2 V2. According to conservation of mass, rate of flow at section 1-1 is equal to rate of flow at section 2-2 is equal to rho 1 A1 V1 is equal to rho 2 A2 V2. This equation is applicable both compressible and incompressible fluid and is called continuity equation. But in case of incompressible fluid, rho 1 is equal to rho 2. Then continuity equation becomes A1 V1 is equal to A2 V2. Kindly refer my notes for your